Okay, so let's try day 17. This one's an interesting one because it's very similar to Conway's Game of Life, except that it's in 3 dimensions. The rules you can see are right here, and they're easy to understand. We have a 3-dimensional grid of cells rather than a 2-dimensional grid of cells. And then let's see. If a cube is active and exactly 2 or 3 of its neighbors are also active, then the cube remains active. Otherwise, the cube becomes inactive. If a cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Otherwise, the cube remains inactive. Those are the rules, simple rules. And they'd like us to start with this configuration here. As the acceptance test. And then this is the response that our system should give, which, as you note, is 3-dimensional. It begins as a 2-dimensional image, a Conway glider, as a matter of fact, a Conway Game of Life glider. But now, in this weird 3-dimensional world, it will split up this way, and you can see the 3 planes here in this case. And as we take it to the next example, it will become 5 planes. And then after 3 cycles, it becomes 1, 2, 3, 4, 5 more planes. And after a full 6-cycle process completes, 112 cubes are left in the active state. So and that's for the acceptance test. Now, starting with your initial configuration, simulate 6 cycles. How many cubes are left in the active state after the 6th cycle? And here's the puzzle input. Okay, so that's what we're going to have to do. Now, are you ready? Let's start our first tomato. Okay, 25-minute tomato. Well, so I thought it would be wise to begin by parsing the input and seeing if we can figure out a way to build our internal data structure. So let's begin. All right. Describe. Yes. Describe day 17, I believe this is. Yep. Okay. And the context is going to be parsing. Okay. It should be able to parse 1 line. Okay, good. Now, what does that mean? Well, should equal. I'm going to start that way, although I don't know what that's going to be. But let's assume it's going to be some kind of string. Should equal. And now I want to parse line. I wonder if this is the right approach. Well, I'm not sure it is. Maybe the line approach is not the right approach. Right? It should be able. Let's back off of this, and let's say it should be able to get the size of the input. All right, that's interesting. Okay, now should equal, and now we can give it a size in 2 dimensions. I presume it should be 2 dimensions, and the size will be, let's say, 2 by 3. 2 by 3. How about that? Just like that. Okay. So now what I want to do is get the size of the input here. So I want to call a function I'm going to call a function. I'm going to assume that this function is going to return a map of some kind. So here, let's give it some input. And the input is going to be a file or a string that came out of a file. And let's just say that this is going to be 2 by 3. So let's see, what do they use as their characters? Hashes and dots. Okay, well, let's just use dots. So this is 2 by 3. Just like that. Okay, so that'll be the input string. We're going to parse it, but what I want to say is this. Now, I'm expecting a tree, a map to come out of parse input. And the element named grid size will return that. Maybe it should be grid. How about this? Dimensions. That's not a bad idea. Okay. Now I need the parse input function, so let's go ahead and create that. We'll just call that the input. Oh. All right. Good. Thank you for that. And yeah, I'm just going to return this. And that should pass the test. Ah, it does. Good. All right. Now, let's try another one. And let's do this. Yes, all right. So that's going to be the return there. Good. All right. Well, let's get a little more degenerate, shall we? We should be able to detect that. Yeah. That sounds about right. This should fail. Yep. Okay. Now we want to. Now what we want to do is implement this, right? So okay. All right. So we're going to parse it. Let lines. Yeah. Be the. I want to just. Split it by lines, right? So this is going to be string / split lines of input. Yes. Okay. And I think I can get the grid size now. So let that's the x and the y value. So let y. That'll be the number of lines. Now the next one would be x, which would be the count of the first of lines. Okay. Okay, let's see if that works. So now I want to say dimension x and y. I believe that's going to be correct. Let's see. Well, it didn't like something. Now, I'm not exactly sure what, although it's complaining about the x and the y here. And it's complaining about the input. So I wonder if I've got some issue here. It doesn't look like I've got an issue here. Let's see. What does it say? Illegal argument let requires an even number of forms. Did I screw something up here? Let's see. Oh, heavens, that was stupid. Yes, I did screw something up. Okay. All right. Okay. Good. So it got a 1 for y. Now, why did it get a y? Well, because there was one line here. It's a line that contained nothing, but there was one line there. I wonder what would happen if we turned that into a nil. And now it fails because we got a null pointer exception. Yeah, okay. So how do we characterize the nil grid, right? Let's go back to this. Oh, no, not that. Let's go back to this. And the nil grid, I'm not even sure this is really necessary, but okay, let's be good about this. If the first, well, if x is 0, then it doesn't matter what y is. So let's do this. Let's say that y is equal to if 0 x 0 y. Yeah, okay. So let's see if that solves our problem. It does. Okay. Well, that's fine. First part's done. Okay. Where's our it? There's the it. Okay, so next. It should be able to we want to build a grid of cells, and that grid of cells is going to be represented by a map of Booleans. A map of Booleans, huh? Yeah. X, Y, Z. Yeah. Okay. All right. So it should be able to build a map. Fine. Okay. So let's describe that. Should equal an empty map. Yeah, an empty map if, and this will be the map of parse input. I'm not even sure that dimensions thing is necessary, but I'm going to leave it there. The map of parse input of any of these doesn't really matter, so let's just do that one for the moment. Now, this will fail because we get nothing there. So now we want to say this. And that should make it pass. It does. Okay. All right, let's try this one. So we're going to take this, and we're going to do that, and we're going to do this with it, and we will take that string and put it in there, and that should have exactly the same result because there are no filled cells, no active cells. So that, yes, that passes as well. Of course it does because we're just returning an empty grid. Now, the next one, let's do this. Yeah, wrong. Let's take this one, and we will do this, and now we're going to do that. Okay, what should this be? This should be, well, let's see, the x is going to be 0, the y is going to be 1, and the z is 0. Yeah, okay. Why did I make this a map? That should actually be a set, shouldn't it? It should just be a set. The set of active cells. So it's not a map at all. It's going to be a set. And so this is going to be the empty set and the empty set. And now this is going to be the set with 0, 1, 0 in it, and the next one is going to be 1, 1, 0. Yes, okay, 1, 1, 0. I believe that is correct. Now this should fail horribly. Yes, good. So now we're going to have to build that. I wonder if I've taken too big a jump here. Well, let's see. Let's see. We're going to have to work out how to do this. We have the lines. So all we need to do now is find the coordinates of those hash marks. So the z-coordinate's always going to be 0 on parsing input. So I just want to get the x and y coordinate. That ought to be pretty simple. So let's try this. Okay. I want to say something like actives, and then do this for so for x in let's see, I want to say ix in x. So x is the number of positions, right? And I also want to say iy and y. Now I'm using iy here. I kind of hate the name, but it's the index of x and the index of y. Okay, fine. Now I want to say equals. This is hard. This is hard. Okay, I'm going to return a list, and the list is going to be first. It's going to be equals hash of the nth lines iy, right? Yes, and nth this is so hard, ix. So I think that's it. Okay, that should be that, and I close the equals. All right, so that'll be a true or a false, and then I just want the ix and the iy. Now I'm going to return actives here, and or you know what? Better than that. I'm going to go back, put that back where it was, and I'm going to put actives in there. Yeah, all right, good. And this is just so that my tests will show what's coming out. And I've got some horrible problem now. I think I did some weird thing. Oh, yes, right. There's a closed brace that I forgot. Okay. And let's see what happens here. Okay. Don't know how to create async from Java Lang integer. Yeah, okay. Let's see, I got that right. Did I get this right? Nth is always collection and then index. Yes, so this is going to be a collection here, so that should be okay. I've got lines, yes. Okay. So where is it complaining? Line 12. Oh, hi.
Hi, did you give the dogs their 12 o'clock?
Not really, no.
Well, doesn't that really
Well, I did give them a little something, but it was very small.
Okay.
So yeah, they can have it. So don't know how to create iSeek. from Java Lang integer. Did I misdo that for loop? I don't think I did. Seems to me that I did that for loop correctly. Although maybe it doesn't like that brace down there. Well, yeah, okay, all right, I get it. Yeah, that should be like range, right? Range X, and this one should be range Y. Yeah. Okay, let's try that. Okay. Got nothing using equals. Well, that's actually correct for one of these. Okay, but I'd like to see this one. So let's take these two and comment them out, and now let's run that test. And what did we get? We got a true for 0, 1 and a true for 1, 1. Well, that is right, isn't it? Okay, all right. So now we should be able to, first of all, filter out just the trues, right? So this is not the actives. This is the states, the cell states. Let's say that cell states. Good. All right. And now we will say active cells is the filter of, and it's the first element, right? So the filter of the first, yeah, I think we just say first, filter first of cell states. And now if I change this to active cells, I should just get those two. Good, excellent. Well, now all I need to do is drop the first element and put a 0 on the end of both, which I think probably would work fine. So I'm going to take this and I'm going to say active cells is going to be map of drop. I wonder if there's a way to, map of rest of active cells. Okay, if I run this one now, it shows me, yep, 0, 1, and 1, 0. Good. All right. I could turn them into vectors this way. All right, so now they're, it didn't make them vectors. There's probably some horrible reason for that, but I don't know what it is. So I'm going to leave that map V off. And now what I want to do is put the 0 on the end. So I'm going to active. This is not efficient, but I'm going to say map of this conj percent 0 of active cells. And I think that gives me that. All right. And now what I want to say is not that, but this into an empty set active cells. Now, I think that's going to work. Didn't work, although it kind of should have. What did I get? I got a... Oh, the conj went on the front. Doggone it. Yeah. I should have spotted that. The conj went on the front because it was a list. If I did this as a map V, let's see what that would do. Yeah, conj still went on the front because for some reason that's not a vector. So, I kind of hate to do that. That's just ugly. Oh, yeah. So conj puts it on the end for a vector and on the beginning for everything else. You just kind of have to know that, and okay, fine. And I really did want it to be a vector, but okay. And okay, it's a little ugly, but whatever. Now, I think that works. Let's try a slightly better one. And oh, by the way, these should all work now. Let's make sure that they do. Yes, they all work now. Okay. And let's see. Should we do any more? Sure, why not? Let's do this. Okay, it's going to be a set of something, I don't know what. And we're going to say the map of the parse input of how about that? That's a good one. I like that one. And let's just run this because it'll tell us what the answer ought to be. And the answer is, okay, 0, 1, 2, 3. Yes, 3, 0 is one of them. 1, 1 is one of them. That's this one. 2, 1, well, that's this one. And 0, 0 is that one. That does seem to work. Okay, so I should be able to take this, copy that into there. Is this cheating? No, this is not cheating. This is not cheating. There's nothing wrong with doing this. I validated it manually and then I stuck it in there. All right, perfectly valid, and that works. Okay, I can now parse the input. That's nice. Given that I can now parse the input and the result is a set of the active coordinates, I ought to be able to work on the rules. And being able to parse an input gives me a reasonably convenient way. Gives me a reasonably convenient way to specify the next tests, which is the reason I started with testing, right? I started with testing because I wanted a way to be able to specify the test data easily. Otherwise, I'd be having to, enter a bunch of coordinates and stuff. Anyway, see you on the next tomato. All right, let's start the next tomato. 25 minutes. Okay. Now, one of the problems we're going to have to solve is finding all the neighbors of a given cell. So given the coordinates of a cell, I need to be able to compute the coordinates of all the neighboring cells. And neighboring means that they differ by 1 in any of the 3 coordinates. Now, if you think about it for a minute, that defines a cube, a 3 by 3 by 3 cube, which has, of course, 27 cubies in it, and the center cubie does not count. So we should get 26 coordinates out of this particular algorithm. So, first test. And this is not a context, this is not a parsing, so let's call this a utility, right? So context, utilities. All right, it should find 26 neighbors. Hi.
Are you recording?
I am, yes. You want me to finish your Diet Coke?
Yeah.
And my own?
Let me take one more sip.
One more sip. Go ahead. One more sip. Yeah, there you go. All right, that's fine. Thank you.
Mine is cold.
Yeah, yours is cold. Mine's a little warm now. Okay. It should find 26 neighbors. Good. All right, that is what we want. And so, heavens, should equal 26. Count of find neighbors, generate neighbors, make neighbors, generate neighbors. How about just neighbors? Neighbors of, and now some coordinate, and let's make it 0, 0, 0. Just because, why wouldn't you? And I want to be very careful about what I do here. Don't want double brackets. Good. All right, well, I need the neighbors of, so let's do that. And lovely, okay, neighbors of coordinate. How about x, y, z? Oh, I know, x, y, z. That's better. We'll destructure it. Fine, whatever. Okay, now what do? We say, well, let coordinates, let neighbors be the 4 of, okay, this is going to be, okay, x, and I don't want to say it that out, ix, for ix is going to be from the range from the deck of x to the deck of x. So one before and the inc of x, because it goes up. It goes from 0 non-inclusive. So if I start with dumb thing, if I start with 0 here, I'm going to go from -1 to 0 to 1. So I almost want that to be the double link of x. Yeah, I'm not quite sure I'm doing that math in my head right. But I think I am. Yeah, I think it's the inc of x. How about this? Plus 2x. There we go. And this one could be -1x, just so that it looks better. Minus x1, yeah, yeah, good, okay. And then plus x2, just so that it's nice and consistent. Okay, all right. And I think that is going to be correct. And then we will do that for IY. It's going to be the range of -y1 and plus y2. And my z will be the range of z1 and plus z2. And oh, won't that be nice? And if we return the neighbors, we will be wrong by 1. Right? It should now give me some horrible, well, it looks like it didn't like what I did, and of course it didn't, because I did not return anything. So right there, I'm going to return ix, iy, iz. Yeah. Okay. Now, let's run that test. And yes, we got a 27, which of course we should have. So now what we want to do is remove the center point, which is the original point. Okay. So what we've got now is a list of items. Well, wouldn't it be nice if that were a set? So let's do this. Neighbors is the into a set of neighbors. And I believe that will change the output here. Not at all. And now we are going to say that neighbors. And now how do you take something out of a set? Set slash, I think there's like a remove or something. How do you take something out of a set? Enclosure. I'm going to look it up here. Sets. Let's see. Yes, disja from neighbors. Let's see. Is this calling as point? Okay, I think I got all that right. Now, are those all the neighbors? Well, kind of hard to believe they're not, but just for grins, let's just look at them. Yeah, okay. How do we make sure that the right numbers are in there? I kind of hate to make a list of all of them, but okay. Here, I know exactly what to do. We'll use that same old trick, right? And let's do 1, 1, 1 this time. And we're going to get that. Now, that's going to be 26. And let's just check them out, right? So 1, 1, 1 is our center point. So, yep, 0, 1, 0, 1, 0, 2. So here, what I'm going to do now is I'll do this offline. I'm going to draw myself a little grid and just make sure, right? So this is going to be... yeah, it's going to be a little harder than that, isn't it? It's a three-dimensional tic-tac-toe board, isn't it? It is. It's a three-dimensional tic-tac-toe board. Okay, so... So everything's fine. You know, I just drew my little three-dimensional tic-tac-toe board. And I screwed up 2 of them. But okay, makes perfect sense. I think it did it right. Should I have done that analysis? It's only 26, right? Why wouldn't you? Anyway, now I can definitely get the neighbors. And let's just take that set. And yeah, we'll copy it in there. Why not? If I can get my... machine to do it for me. Stupid thing, come on. There we go. Copy it, paste it in there. Bing. Yeah, I know it's long. Well, that's okay. So what we're going to do here is this. Now maybe I should have done it by 6s instead of 3s, but you know, whatever. And I believe that's going to work. Yes, it does. Okay, fine. Now I can find the neighbors. Lovely. Okay, well, having found the neighbors, what should be the next thing that we do? Well, we want to know how many of those neighbors are filled. And we don't care which neighbors are filled. We just want the count of the neighbors that are filled. So, it should find the active neighbor count. Okay. Well, let's start out with the degenerate case. Degenerate case is going to be should equal 0. Let's see, active neighbors. Yeah, active neighbor. Yeah, active neighbors. That's fine. Active neighbors of And let's give it a map, or the set, active neighbors of 0, 0, 0 in some set which we will be empty. Okay, so now clearly there are no active neighbors. We can create our little function here. This is going to be the cell, and this, you dog. Okay, and this is going to be the cell. And this is going to be the world. We'll call that the world. Okay. And we'll just return a 0 because that's what should happen here. Good. And let's just return a 1 to see it fail because that should fail. Yeah, okay. All right. 0, 0. Yeah, all right. Fine. All right. Now, let's do this. All right. Where's our it? Yeah, okay, that looks good. That looks good. Let's see. Parenthesis goes there. Good. All right, let's get that. And let's say that we should have a count of 1 if there is an active cell at 1, 1, 1. Now, I believe that's true. Right? Yes. Okay. That should give us a count of 1. Okay, we got that wrong. All right, now let's go up here. Well, this should not be really hard, right? So, first of all, we say is there some ugly thing there? Is it on my screen? Man. All right, yep, okay. So let neighbors be the neighbors of the cell in the world. Now, oh, yeah, of the cell. Yeah, good. Yeah, that's just the neighbors of the cell. Good. Now, let's get, what do we want? We want the, well, is it a set? Does neighbors return a set? Did I have it return a set? I think I did, right? Yeah, right. Does it into a set. Good. Okay. So neighbors is a set. Well, what's the intersection of the neighbors and the world? Right? So active neighbors. Did I spell neighbor correctly? I think neighbors. The active neighbors is the set / intersection of the neighbors and the world. And I just want to return the count. G. Ah, that worked. Okay. I think that's really about it, isn't it? Let's just try a couple of other interesting cases, like does it do negative numbers properly? So -1 and -1 and -1. Let's see if it does those right. Should. Yeah, it does. Okay, let's try the 2 case. So let's do this. This should be a 2 of 1, 1, 1 and 1, 2, 1. That should all yeah, that should definitely be part of it, right? In fact, let's say 1, 2, -1. That should definitely be part of it too. And in fact, yeah. Okay, fine. So, oops. Only got 1. What did I mess up here? So 1, 1, 1 is 0, 0, 0 is the coordinate, right? So yeah, 2's not going to work. 0 will. Yeah. Okay. Yeah. Okay. I believe this works. All right. Okay. It's finding the active neighbor count properly. That's good. Now what we want to do is we want to scan the entire world, right? looking for neighbors. Now, the first rule is the if it's active rule. And let's just remind ourselves of what that rule is again. If a cube is active and either 2 or 3 of its neighbors are also active, then the cube remains active. Otherwise, the cube becomes inactive. Oh, there's our tomato. All done. See you on the next tomato. All right, let's start the next tomato. 25 minutes. All right, so let's take the active case first. What we want to do is search through the whole world, find all the active cells, which is exactly what we have in our set, and count the neighbors for every active cell. And if that number is a 2 or a 3, we will leave that cell active, otherwise we remove it. I think that's pretty straightforward. So let's say it should remove what's a good way to say this? It should remove cells with less than 2 or more than 3 neighbors. Long sentence. Okay, fine. Okay. So, given a cell, let's see, should equal. Okay. How could we do this interestingly? Should equal 0. Yeah, the degenerate case first, right? Should equal 0. The count of the remove actives. What should we call this function? Remove active cells. Remove is not quite the right word. Update. Update active cells. Good. All right. Count the update active cells of the world. That's really all we care about is the world. Well, what's the world? Well, the world is a set. And that set is going to be empty. Okay, so that should be 0. Okay, there's the degenerate case. That is the right degenerate case. Lovely. Let's do that. Create the function, update active cells. Good. This is the world. Okay, lovely. Cannot seem to get that down properly. And we're going to return a 1, which should fail. And we're going to return a 0. No, we're going to return an empty set. Which should be fine. Good. Okay. Now, let's get down to brass tacks here. Let us say that should equal 0. The count of update active cells of a world that has 1 cell in it. And that 1 cell will be 0, 0, 0. That should also be a 0. Which, of course, yeah, my test passes. Okay, all right. Let's see now. I want a case where updating the active cells will leave 1 in place. All right, we're going to update the active cells. it just occurred to me just how tricky this might be. There's an order issue, isn't there? You have to create cells and then you have to remove cells, and you'd better create cells before you remove them, but that isn't even the right approach. Let's see. We want to get the candidate cells for removal. Yeah. Which cells should we remove and which cells should we add? We don't want the world to be affected by the current turn, right? We want to process all the additions and all the removals, and then once we've got them all enumerated, then we can change the world. Yes, right. Okay, all right. So I think I've got the wrong approach here. This is not update active cells. This is get cells for removal. Ha! Yes, all right. So we're going to change that name. If I can figure out how to do that. Oh, yeah, all right. Get cells for removal. Good, okay. We're going to refactor that. Now, again, that's going to be 0. And in fact, in this case, I don't even think I want the count. I think I want just the empty set. And cells for removal, well, in this case, it's going to be that, right? Because since it's the only cell in there, it's got to be removed. Let's get that to work before we do any of those. Okay. And this should not be a count, by the way. Good. Okay. All right. This should now fail. Yes. Okay. Get cells for removal in the world. Well, at the moment, I could make this pass by returning the world. So that'll make it pass. Okay, let's do just a little bit better than that. Get cells for removal. Okay. I'm going to do this for the moment. I'm not quite sure how to deal with this. And let's do this. Get cells for removal of parse input of... Okay, now we can actually do something real. If we say pound, well, yeah, that would be good enough, right? Just that. Okay, so that's going to be the cells for removal are the ones on the two ends. So that should be 0, 0, 0, 0, and 0, 2, 2, 0, 0. Yeah, 2, 0, 0. That should be the cells for removal. And we didn't get that right, so okay. Parse input is wrong. That should be the map of the parse input, which now makes me kind of wish I hadn't done that, but okay. And he returned the world, and the world was 1, 0, 0, 2, 0, 0, and 0, 0, 0. Right, okay. And 1, 0, 0 is the one that should be remaining. So now we need to do the work. Okay, all right, so now we got it. Okay, so what we want to do is for each element, for each element in the world, okay, so let removed cells be the for loop of cell world. Okay, so we're going to loop through the world for each cell in the world. This is going to be really weird, isn't it? Okay. Get rid of that for the moment. Get rid of that for the moment. Get rid of that for the moment. Okay, here's the for loop. For each cell in the world, I'm going to remove the cell. Remove cell, cell world. Yes, good. Okay. Now, right there you might be wondering what I'm doing. Okay, so let me explain that to you. Removed cells. Yes, okay. This function, remove cell, is going to return the cell if it should be removed and nil if it should not be removed. So this list here will have a bunch of cells and nils. And then I'm going to filter out all the nils. That's my plan here. So let's create that function, remove cell. Now you're saying, well, Bob, you need a test for this. Okay. Given that I have the world in the cell, I'm just going to ask if, so this is set slash member. I want to know if it's in there. And I think you can do that this way. I think you can say world cell. I think you can do that. If you pass in a set as a function, then the argument will be a member and it'll tell you if it's a member. And so if it's in the world, well, of course it's going to be in the world. What the hell do you think? Well, okay, that's probably a reasonable... No. Screwed that up. Okay, all right. So, let neighbors be the neighbors of the cell. That makes perfect sense. Okay. Now I want to get the count of neighbors of that cell. And what did I call that function? Active neighbor. What did I call that function? Active neighbor. What's dumb name is that? Active neighbor. Should be active neighbors, right? Why did I call it active neighbor? Good grief. All right, so how about neighbor count? Yeah, okay, active neighbor. How about neighbor count? Let's call it neighbor count. Okay, that's good. Neighbor count, all right. So we go back up here and we say neighbor count. N. Neighbor count. It's the neighbor count of the cell and the world. Now, I don't think I need the neighbors therefore, so because neighbor count does that for me. So that's going to be the neighbor count of the cell in the world. Good. Okay. And I don't know what those parentheses are. And then, well, given that, I should be able to say if less than, so n2. So if n is less than 2, and now I want an OR here. And I'm going to say greater than n3. Something like that, yeah, okay. Then we should delete the cell. Otherwise, we return a nil. I believe that is correct. I think that is right. Yes, that's good. So that can go there. And this is right there. So there's one missing parenthesis. Okay. And with that, we got, I don't know what the hell that is. So this should have worked. Remove cell, that worked. Okay, so expected the empty set, got an empty list. And that makes perfect sense. So into a set, removed cells. Yeah, okay, fine. And I think that does everything that I wanted. Let's see. What we get now, and we get, excellent, look at that. Okay, good. Okay, so now all we have to do is filter out all those horrible nils. So let's see, remove cell, blah, 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 yes, yes, removed cells, right, okay. And let's just filter. What am I filtering? Sum, I think. Isn't it sum? Yep, that's it. Okay. Right. Okay, turns it back into a set. That's nice. Good. Everything is happy here. That's lovely. Let's see. What other tests can we run on this? That was actually a pretty good test. Do we have the overcrowded case? No, we don't have the overcrowded case. So let's try that. And I don't know what to call this yet, so we'll just do that. And then we'll say get cells for removal. And we'll say the map of parse input. And this is going to be pound, pound, pound. Pound, pound, pound. Pound, pound, pound. Okay, what's it going to remove here? Well, every cell has too many neighbors. So it should remove them all. I think it's going to remove all 6 cells. Is that true? Let's just see what it does. Now, it only removed 2 of them, which is 100 and 110. So it only removed... Oh, I see. Yes, because the top left corner has 3 neighbors. Yeah, okay, got it. Yeah. Okay. Yes. Okay. So, which ones get removed? The 2 in the middle. The middle column gets deleted. Yeah. Okay. So that's right. Okay. I believe that is correct. I'm trying to work that out in my head, but I think that is right. Okay. Let's assume that it is for the moment. Then that should close that. Now, it should add cells with, and what is the rule here? Exactly 3. It should add cells with 3 neighbors. Okay. So I think we know how to do this one. We'll do it the exact same way. It's going to be sets. Get cells for addition. How about get new cells? Get new cells. And we'll just pass in the empty set, and that should return the empty set, and life should be good. Okay, so let's do that. Okay, that's the world. I don't think we need anything else there. Good, and we'll just return nil. That should fail. Good, and now we're going to return the empty set, and that should pass. Oh, heavens, I never did that, did I? Yeah, all right. So let's go back down here and put that in there so that that will all pass. Lovely. Yes, it all passes. Lovely. Okay. So if the world is empty, it's going to stay empty forever. Now, how do you create? You create a new one. I'm not quite sure what that's going to be, but get new cells of that. Okay, now there are 2 new cells to add. The one in the middle above and the one in the middle below. That's the way I read that. So, what are the coordinates? And the coordinates should be, I gotta be real careful here, because yes, it's the one in the middle above and the one in the middle below, but there's also one in the middle in Z and minus Z. Yeah. Okay, so this is going to be 1. The x-coordinate is going to be 1. The y-coordinate is going to be minus 1. And the z-coordinate is going to be 0. 0. Yeah, right. Good. Okay. Yeah. So that's the one above. And then the next one is going to be the one below, which is going to be 1, 1, 0. Okay. And then the next one is going to be 1, 0, 1, different z coordinate. And the last one is going to be 1, 0, minus 1. I believe that is correct. Ha! That'll fail. Okay, let's see if we can run that one. Now the trick to this one is that we're going to have to grow the world. Or at least we're going to have to look beyond the current bounds of the world. Right? So we cannot simply look at the cells within the bounds of the world. We have to look at the cells that are one coordinate beyond the cells of the world. Now, I don't think that's going to be too difficult. So, let's do this. We're going to say let, okay, let yeah. let coordinates be the 4 of, all right, Ix is going to be the world does not tell me its dimensions, does it? Okay, I need that. Thank you. End of the tomato. All right, let's start the next tomato. 25 minutes. And the world doesn't have anything in it that specifically tells us what the dimensions of the world are, but we can infer it from the minimum and maximum coordinates in each axis, right? So what we're going to do here is we're going to get the bounds of the world. And to do that, I'm gonna delete this, whatever I was doing here, because I don't know exactly what that was now. I'm going to go back down here, and I'm going to say, okay, yes, that's going to fail. But I want to have another test here. And that test is, it should calculate, it should find the bounds of the world. Good. Okay. Now, the bounds of the world. Okay, the bounds of the world are going to be, let's see, what do I want to say here? I want the min and max of the 3 coordinates. So, let's see. Before I do that, let's just check what the input is going to be. So, get bounds of... All right, now I want the set of the world, and the set of the world is going to be empty. Okay, this is the degenerate case. What are the bounds of this world? And the bounds of this world are all zeros. So this should be 0, 0, 0, 0, 0, 0. Now, it's a little bit of a stretch, because a world with no active cells doesn't really have any coordinates at all. Okay. But let's just go with it for the moment. Get bounds, yes, create function get bounds of the world, lovely, okay, and we're going to return nil, because that should fail, it does, and then we're going to, oh, yeah, maybe I should turn that other one off. Yeah, well, this is the one here. That's the one I was really interested in. But let's go down and turn that other one off, because that one's not really helping me for the moment. So let's just comment that one out, and we should get only one failure. Good. And now, get bounds, we will return, 0, 0, and that's the min and the max, right? 0, 0, min and max, and 0, 0. So the min and the max of the x, y, and the z coordinates. And, okay, that worked. Now, should equal, and I don't know what to put here yet, so get bounds. Now we're going to just create a single coordinate. And that coordinate is going to be 1, 1, 1. Okay, what are the bounds of this world? Well, the bounds of this world are 1, 1, 1, 1, and 1, 1. Yeah, that's pretty straightforward. Okay, that's going to fail. Okay, so now we go back up here and we say, all right, we're going to get bounds of the world. So, yes, what do I want to get? I want to get a list of all the coordinates. I know what to do here. Let's see. So let's get the x's. The x's are going to be a map of the first of the world. Right? Yes. Okay, and we're going to return from this. Let's see. A list with the first list is going to be the max of the x's, and then it's going to be the min of the x's. I think that is correct. And this is going to have to go like so. Oh, heavens, no. This is going to have to go like so. Yes, that's better. All right. I'm fine. Good. Yes. All right. Run it. And what did we get? Oh, we didn't get quite what we wanted, did we? So what is x's here? Here, let's just put that in there like so, and we should see what x's is. It's an empty list. Map of the first of the world. Oh, it's this first one that's failing now. Oh, yes. All right, fine. So let's go down here. And this one was passing before, but I'm going to comment it out because I want to see the other one. All right. That's much more interesting. Yes, 1 and 1. Okay. And we see that there's a little bit of a problem there because it put that into a list which is bizarre. So let's fix that. So we don't want this. I do want a vector. And the vector is going to be containing another vector with the maxes and the mins. Not exactly what I had in mind. Why is it putting that 1 into yet another list? Yeah, dumb. So now what I want to do is apply max and apply min, and I don't think you can do that because they're macros, right? Oh, well, no, that worked. Okay, I guess you can do that. Well then, the y's are a map of the second of the world, and we're going to add apply max y's and apply min y's. Yes, all right. And that should give us, it didn't really work, why not? Because that should be y's. Good, all right, now it should work. Yes, that looked good. And the last one, well, there is no third. So the z's are the map of the nth to world. Let the reader understand. And this is going to be what? Apply max z's and apply min z's. And that should give me exactly what I want. Yes, it does. All right. Clean this up a little bit. That's pleasant. Okay, good. That gets me the bounds. And let's just check that the bounds are working properly, although I believe they are now. And let's undo this one at first, and that one should... Oh, it did not work. Why not? Number of arguments passed to core max is 0. Oh, heavens. Okay, yes. Okay. That is the funny case, isn't it? So, best thing to do there is to say that how much do I hate this? I believe that is what I want, and now we're going to repeat that for the three of them. And yes, there's probably a better way to do this, but I'm not going to do it. I could write a little function, I suppose. You know. Expected 111 got 0000. If empty XS, then I wanted oh, yeah, question mark. Yeah, there is a function called empty. I wonder what it does. Huh. Yes, okay, that's what I wanted. All right. So bounds is working better. Now let's check one more bound. And should equal, and I don't know what that's going to be, so I'll come back to it, get bounds. And now the set is going to be 1, 1, 1, and 3, 3, 3. Yeah, fine. Good, okay. And of course I did not specify that set correctly. I think it's okay now, except of course the doggone thing puts all kinds of goop in there because it doesn't know what the heck I want. Good, yes, all right, yes, and I believe that's going to be 313131. You know, that makes perfect sense, doesn't it? Yeah, okay, so let's take that, and we'll just take that, and we'll copy it right in there, and yeah, okay. Believe that should work. Okay, those are the bounds. All right, let's get back to this one now, because this one's the interesting one, right? And this is failing at the moment. Good. All right, now back up to here. Get new cells. Well, get new cells is going to have to call get bounds, so I'm going to move that down. Okay. We're not going to return the empty set anymore. Here's the world. Okay. Let I'm just going to destructure the whole thing. It's max first and min, right? Yeah, it is. All right, and okay, that destructures it all. Okay. Now I want to shift that, right? So I'm going to say the max x. What did I just do? Man. Okay, this is going to be really tricky here. Yeah, okay, so I got to do another one of those. Okay. To balance that one right, and then this is going to be get bounds. Get bounds of the world. Okay, good. That is correct. And if I want to be maybe a little nice about it, I could make it look like that. Okay, next. Max x is inc max x. Min x is dec min x. Yes, I am going to do this for each one of them. Sorry, I just am. I know there's a better way. Oh, man, inc max y. Yes, I'm going to do this. I am going to do this. min y is the deck of min y. Yes, all right, good. And max z is the inc of max z, and min z is the deck of min z. Okay, that increases the bounds. Now what I want is to walk through all the coordinates and do the exact same thing I did before, right? I'm going to look at a coordinate. I will ask for its neighbors. I will get the count, and if the count is 3, I will return that position. So, additions. What did I call the other ones? Added cells. Added cells is going to be a for loop of ix for range of min x to, doggone it. Add one. Do you have to add one? Yes, you have to add another one, Bob. Inc max x. Yes. Yes, you have to do that. Sorry, Bob. Yes, you do. All right. There's the range. Iy is going to be range of min y to inc of max y. Yes. We really are going to go through them all. Yes. And iz is going to be the range of min z to the inc of max z. Oh, yes. Lovely. Okay. Fine. Thank you. What are we going to do inside this? Well, he said, what did we do in the last one? We said remove cell. Right. Okay. So we're going to say add cell. And what cell are we going to add? Ix, Iy, Iz, and world. I think that was the way we did it before. Remove cell, cell, world, yes. Add cell, cell, world. Yes, exactly what we want. Okay, good, lovely, wonderful. That'll be the added cells, and then at the end of that, we're going to filter, just like before. And we can actually do that outside of the bracket. So we can say filter sum. Was it sum or some question mark? I can't remember. Where's that? Filter sum. Yeah. Oh, yep. We got to put it into a set. Yeah, that's right. Okay. So we might as well do this. Added cells is the filter of some question mark added cells. Good. Lovely. And then this is going to be the into of the set of added cells. And that closes the let, and that closes this. Good. Let's go get add cell. Okay, add cell. Add cell is going to be cell and cell and world. Thank you. Okay, should I add this cell? All right, well, count neighbors. Neighbor count of the cell and the world. Yep, that's it. Okay. if equals n3. Okay, this is an interesting one. Because I don't want to add a cell if it's already in there. Although that really doesn't matter in the slightest, does it? Because if I add a cell that's already there, it's just going to add, it doesn't mean anything, doesn't change anything. So I don't think this matters. So I don't think I have to check. All right, if n equals 3, okay, then cell, otherwise nil. Yeah, I think that's it. I think that's it, guys. Okay, what did I get? Well, I got a lot more than I thought I was going to get. I got 1 minus 1 minus 1. So did I get anything that I wanted to get? Yes, I got 1, 1, 0. I got 1, 0, 1. Good. I got 1, 0 minus 1. Good. I got 1 minus 1, 0. Did I get that one? 1 minus 1, 0. Yes, but I got others. I got 1 minus 1 minus 1. Is that really a case? So now I got to think through this. So it's telling me that 1, so here I'm going to use the mouse. 1 minus 1 minus 1 coming out from the screen. Ah. Yeah, it is 1, isn't it? And that would mean that 1 minus 1 plus 1 would also be in there. So do we see that one? Yes, 1 minus 1, 1 is in there. And then you'd see the two alternate cases of that. There'd be the 1 minus 1 minus 1. Yes. And 1, 1, 1. Oh, yeah. So, yeah. This is more correct than my test. That's the problem. You can't work out what the test is, right? So, okay. And here, let's just kind of organize this a little bit better than that, if we can. Yeah, not great, but okay. Well, that's how you add a cell. Okay, so now we just want to add a cell. We want to remove all this, remove all the cells. All right. So, what is the final situation here? Well, let's do this. Let's go get the acceptance test. Let's do it with the acceptance test. All right. Those are the utilities. So let's do context acceptance tests. Okay. And this is going to be, it should pass day, it should pass day 1. Okay, fine. Part 1. Good, okay. All right, let's see. We would like... Well, to do this, I'm going to want to go here. I'm going to want to put this in. That's our acceptance test. And then I'm going to want to check it against that. Now, this is ugly. So, how would I do that? Well, Bob, what if you could parse that? This would be an interesting thing to parse that way. And it would be an interesting thing to parse this way. So that would be parsing the input to create more layers. Well, all right, let's see what we can do about that. Yeah, so I'm gonna, well, that's the tomato. Okay, next tomato. All right, well, I got myself a little lunch and I walked the dogs, and now it's time for another 25-minute tomato. Okay. All right, so before I do this acceptance test thing, I'm going to just undo this again. Because, while I'm eating lunch and worrying about stuff, I'm thinking, I need to parse this, right? I need to parse this thing here. And that'll help me express my tests a lot better. And you can see there's this z equal thing in here. So let's just do that. Let's get back up to the top here where we have our parsing. Okay, well, we do have to parse an input that does not have a z in it. But I should also parse things that do have a z in it. Now, that's kind of interesting because this parse input function parses a plane with z equal to some constant. And I assume it's a 0, but I wouldn't have to assume it's a 0, would I? Okay, so gee, let's do this. Let's say, let's see, what's that? That's that context for parsing. Good. Let's say this. It should parse maps with z's. It should parse maps with z equals. Now, simple case. Let's see. Should equal. I don't know what it's going to equal. It's going to be some set. Okay. The map. I'm tempted to get rid of this map thing now because I don't need those dimensions, do I? I'm going to leave it for the moment. Parse input of z equal to, I think now let's take a look at the, z equal to \n and then pound. Good enough right there, just that. That should be enough. Now what should that return? Well, that should return the set with 0, 0, 2. That's what that should return. And bad things are going to happen, right? Because, it's string index out of range 1. That's at what location? Yeah, terrible things are happening here. Of course, back blah 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 13. So there's a number of things that went wrong with this at 13. It says, right, because we assumed this. We assumed that we could count the lines and count the first lines to get the bounds. Well, I have a thought. Let's change the name of this to parse plane. And let's add the plane, the z coordinate. Now, that's interesting. Let's see if we can do this. This is where we're adding the z-coordinate here. Now, I know. No tests, right? Yeah, I know. No tests. Well, we do have tests, sort of. Because I'm still going to call parse input. And parse input is going to call parse plane. So, let's come down here, and we're going to say defin parse input, taking the input. And I'm just going to turn around and say call parse plane input 0. Now, so far, I believe that will work with the exception of the one test that I have that is failing. And let's go back down here, and we'll just delete that test for the moment. Which is this one, right? Yeah, so let's take this test right here, that whole thing, and we'll just comment that out. And I don't think anything broke. Right, okay, so I haven't broken anything. All right, now let's go back, and we will undo this. Okay, now, can I take this parse input and have it parse Z's? Okay, so I'm thinking this is possible. I'm thinking it's possible, and here's how I'm thinking it. Let's say that we have planes. Let the planes be string/split the input and the regular expression z equals something. Z equals \d dot \n. Okay, got that? Got that, guys? See that? Now, I want to take that and put it out there. And then I'm going to say, okay, everything else is the same. I'm going to turn this into first plane. Now, I think that'll work. First planes. Okay, now I believe that will still work. No, it didn't work. Okay. Parsing should parse maps with string index out of range in 13. Same thing. So before I go any further, let me do this. And we're just going to see what happened here. Well, actually, an awful lot of very interesting things happened there, didn't it? It really was doing an awful lot. Now, it's difficult for me to even see what it did, although it did print the z equal 2 thing. Interesting. Now, it's possible that you can't split a string beyond a line. That's possible, although I'm not sure I believe that. So, let me do, well, let's just, a little bit difficult to work this out, isn't it? But, it is kind of the idea that I want. I just don't know if that's working. Well, Bob, let's go into the REPL. Alright, so line REPL. So string slash split, and here's my thing, and I'm just going to say z equals 3 backslash n, and then abc backslash n, and def backslash n, and then z equals 2 backslash n, and then 1, 2, 3, and backslash n, and that's good enough. And the regular expression will be z equals a digit dot, digit plus. Yeah, that's what I did wrong, isn't it? Backslash n. Now, and runtime no such namespace string. Closure dot string. Let's go to the end. Yeah, that's exactly what I want. Okay, all right. So I just had the wrong regular expression in there, didn't I? So the regular expression is not dot, Bob. It's plus. And let's see what happens now. Well, that was better behaved, wasn't it? And what did I get here? I got nothing using equals where I expected a 0, 0, 2. And that is, should parse maps with z's. All the others seem to work. That's good. So this worked fine. It's just that the z didn't work. And let's see, what did it do? So, where's my parse input here? It did call parse plain. It did parse it with 0, I think, but did not put the okay, parse input, blah, blah, blah. So what was the test that failed? Test that failed was this one, where the parse input of the z equals, and then that did not yield a 0, 0, 2. It didn't yield a 0, 0, 0 either. It just yielded a nothing. I find that to be a little bit bizarre. But it should have parsed the first of the plain. Let's look at that again, the REPL again, and see what that... Yeah, see, it got me that. So the blank line, it did match the z equals, right? But that first z equals came out with a blank line in it. Now, that I find to be interesting. That blank right there, that's interesting. Everything else seems to be fine. But that blank is interesting. I'm also not exactly sure what I'm going to do about, the the z equal part of it. So, heavens. What if I were to do this? Instead of splitting it, see, that split is eliminating the z part, and I want the z part. You know what? I might just be spending a little bit too much time on this. Let's not do any of this for the moment. I might have to come back to it. And I'll leave this parse plain thing in place. But let's just let's just go away. Get rid of that one test and try this a different way. So this is the test. I'm not going to parse with the z in it, not just yet. Let's go back to the acceptance test. Maybe there's a way to write the acceptance test without too much fuss. Let's just see. All right, so okay. So let's get the this. Okay, that's our input. That's that. Okay, that's our input. Good. And I believe that's all we need. Parse input. Yep. Of the map. Yep. Good. Got it. Okay, that's our input. Okay. Now, should equal. What am I going to do here? Well, I have an idea. What they're asking us to do is count the number of cells. That's what they want us to do. Count the number of cells. Okay, well, let's do that. After one cycle, the number of cells is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Should be 11. Okay. Let's do one turn. Yeah, let's do turn on the input. Okay. And I want to count that. Because the output of do turn will be the set, and the number of active cells is just the number of elements in the set. Okay, let's do that. That should definitely know that, that this is this. It shouldn't complain about that. Okay. All right, all of this looks good. So let's get do turn written. Dog. Create the function do turn, which takes a world. All right, now, what do you do? Well, let deleted be, what is the name of that function? Delete cells. Remove cells. Got the name of the method. Get cells for removal. Yeah, okay, fine. Yeah, all right. Where am I? So we'll call it removed. Get cells for removal. Good. Of the world. That's all I need, right? Added. Get cells. Get new cells. World. Okay. Okay, now, what is the result? The result is going to be the set union of added with the set difference of world and removed. I believe that's correct. Let's just take a look at set difference. Returns a set that is the first set without the elements of the remaining sets. Yes, okay. It is the first set without the removed elements. Good. I think that's it. I think that's the whole thing. I think that's how you do a turn. Let's see what happens. Okay, we had a little problem here. Looks like I tried to add a nil to a spec. Oh, heavens. Some horrible... Oh, yeah, right. Right. Yeah, context acceptance test part 1. How about this? Yeah, okay, so that should go all the way to the describe or the context utilities. And then this is going to be what? The describe day 17. So this is context, acceptance tests, and it should pass part 1. Okay, and then this is going to be like that, and let's run that. Oh, heavens. It passed part 1. Okay. Now, let's continue on with this. Okay, now I want to say, after 2 cycles, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, now that's a little bit weird. And maybe what I should do is create some new function. Right, so like this. Something like that. Okay, let's do that. Jeez, there's no... Okay, fine. Okay, well, now we're just going to run that n times. So, there's got to be a way to do this. It's almost a reduce of some kind, isn't it? But it's not, so okay. Loop n loop n world. Okay, fine. This is going to be the world. Yeah, okay. Fine. Where's the end of this? Yes, okay. So that. All right, and we're going to say if 0 n, then return the world. Otherwise we're going to return. We're going to recur dec n with the do turn of the world. I think that's the whole thing, isn't it? Okay, fine. And that seemed to work just fine. So now we can do the last of the acceptance tests, which is this. After 6 cycles, 112 cubes are left. So, okay. And that looks like it, is running forever. I think the last one was running forever, too. I think I screwed up here. Let's just see. Did I screw that up? Do turns and the world, right, if 0n. Well, that ought to work. Okay, tomato. All right. Now let's start up another tomato. 25 minutes. Probably the last one. Cross your fingers. Okay. Is this infinite looping? Now, I don't know why I thought it was. Let's just see. Yes, that does look like an infinite loop. Not printing anything, not saying anything, just kind of hanging there. That sort of looks like an infinite loop. All right, so let's stop it. Why would that be infinite looping? Well, Bob. Here, let's do this. Println n. Now, I mean, I expect that that's going to print an infinite loop somewhere. No, it's not printing in an infinite loop. Okay, wait a minute. That's not the way this is supposed to work. I've got some other problem here. Hold on there, Newt. Do turns. First of all, let's get this one commented out. Let's get this one commented out. And let's run the tests. Now that should not be an infinite loop, because everything was working well. Oh, heavens. Oh, okay. Yeah, all right. That's the describe. What's missing here? Was it this it? Oh, no, it's not that it. So something up here. Something up here, Bob. Gee whiz. Do turn. Yeah, okay, good. Do turns. Bob, you nitwit. All right, there. I think that's probably better. Yes, okay, fine. And now let's come back here and let's undo that one and see if it works. It does. Come back here and undo that one and see if that one works. And, oh, heavens, no, it doesn't. Unmatched delimiter. That must have been here. So there's the it. That's the context. That was the describe. So that one's extra. Right? Yes. Okay. All right. So, and here, yeah. All right. And now we'll run it. And, all right. Acceptance test passes. Okay. So now let's solve the problem, shall we? Solve part 1. All right. Solving part 1, we need to read that input, right? So, should equal 0, solve 1, and then I don't care what else, right? Okay. All right, so let's go get solve 1, and solve 1 is going to say, well, let the input be the slurp of input. Good. Yes, that's fine. And by the way, we ought to go get that. So let's go get it. Here it is. All right, there's the file. Oh, heavens. Yes. Okay, fine. And we're going to take that and we're going to add it into our project. Call it input. And add file to Git. Yeah, you can add it to Git. Sure, fine. And put that in there like so. Lovely. That should be fine. Good. And now let's go back to our spec. And I think I can probably do that. Yes, okay. So now we're going to do the input. Slurp it. Good. Got it. Lovely. And I believe the only thing I need to do after that is return the count of do turns. 6, is it? How many times do they want us to do it? 6 cycles. Do turns 6 of input. And you know, parse. Yeah, map of parse input of input. Ding. Well, let's see what we got here. And what does it say? Runtime unable to resolve symbol do turns. Why? Oh, it's do dash turns. Huh. 298. Okay, well, is 298 the right number? keep your fingers crossed. Oh, that's the right answer. I got 1 gold star. Okay. All right. Well, that's pretty good. You know. All right. So let's go over here, right? And take the 298. And we're gonna put that in the last test. Yes. All right. And that should make everything run. Oh, lovely! Isn't that nice? Okay. Now, I'm gonna just check to see what part 2 is, because I may not want to do part 2. This has already gone on for a while here. Let's see. Yeah. Oh, 4-dimensional grid. Yes. They want us to do it now in 4 dimensions. No. I've already kind of done this, so I think we've had enough. I don't want to do multiple dimensions. That's good enough. I don't need the gold star. So I think this is pretty good. That's good enough for this video. Good enough.